right, welcome back to another Perspectives podcast with your two hosts, James McDuffie and
I'm BC Lee.
We are here today to talk about AI. Now, AI is kind of a hot flash topic these days, so hopefully the conversation is a good one. You have a little bit of experience since that's kind of my industry, and then BC today will be kind of the guy that asks all the cool questions. But let's start it off with a little bit personal. How was your week, BC?
Well, one of my clients came into the gym with an ice cream cone in his hand.
I have no idea who you're talking about.
And
Sarah.
a Mountain Dew in the other.
What? A what in the other? What?
A Mountain Dew. Yes. So that was a first. I also have a toddler who's leaving surprises for me around the living room.
Oh, that's not good.
Family room and the kitchen. And the dog decided he would get in on the action.
Wow, you had a big week.
He's now leaving me the same kinds of surprises. So that's, morning wake-ups every day. It's a problem. But
Sorry to hear that.
first world problems.
Yeah, first world problem. Ain't that the truth?
Can we still say that?
Yeah, of course.
Okay.
Yeah, totally. Not super PC on this channel. Don't get me wrong. I like to be cognizant and aware and kind to other people. So I think it's important to show kindness. But I think as long as there's humor, a little bit of.
I'm showing gratitude and gratefulness for living where I live.
Yeah, for sure. I think my week's been pretty good. I hurt my shoulder doing a lot of swimming over Christmas break, and it finally gave out on me last week. My friend Greg and I were doing a whole bunch of extra shoulders, and it just started popping. And so I've taken a lot of Advil, anti-inflammatories, and a lot of icing, and it's not popping today, although it's still a little sore. So more anti-inflammatories, more icing, and hopefully by the end of next week, I'll be ready to go back to the gym.
Probably at this phase, you need some heat.
Yeah. So I do that in the shower in the morning. I just super, super hot and just kind of sit there for like 10, 15, 20 minutes.
I think you need some steam room.
Yeah. Oh, yeah, the gym. Yeah, we go to the gym, and there's a badass steam room there, so we'll have to hit that this week for sure. Okay, so let's jump into today's topic for those of you that are interested in AI. Look, a little bit of background on me, for those that don't know, is I am a senior technical advisor to Fortune 500 companies, and I work with computer science, engineering, AI, large-scale cloud compute every day. So I'm talking to CEOs and CISOs and their directors of engineering and their product management teams, and understanding their use cases and really just breaking down how they can utilize UI in a real world fashion.
For those not in the know, what is UI and what's a CISO?
Oh yeah, good questions. So UI is user interface. Mm-hmm. So anytime you're talking about user interaction design and how people use software, then you're talking about UX, UI, and how that works.
You can't define an acronym with another acronym. What's UX?
Yeah, so UI is user interface, and UX is user design. So user design or interaction. The X is like a user experience is where the X usually comes from. Okay. And then when you talk about CISOs, so CTO is Chief Technology Officer, like CEO is Chief Executive Officer. CISO is Chief Information Security Officer. So, I work with CISOs and CTOs, so Chief Information Security Officers and Chief Technology Officers in their vision for AI as they expand their technological portfolios.
Does every company that has a CTO have a CISO as well?
That really depends on the company. Some companies absolutely have CISOs, and other ones just, they have somebody in their engineering team that acts as a security person. Okay. So, sometimes it's good enough. It really depends on how the company is structured. And the weird thing is every company is structured almost completely uniquely. Sure. There's some, pretty classic roles like Chief Technology Officer or Chief Executing Officer, CEO. But some companies only have CEOs, right? They have CEOs and then an engineering team. Depends on the scale of the company and, how large they actually have to scale to have those separate responsibilities.
Okay.
Yeah. Okay. Sweet. So let's kind of jump into AI. What is it? How does it work? This is kind of I like to describe modern AI, which is large language models, as a gumball machine. Now, that may be a little hard at first, but the easiest way to think about it is I'm going to put a quarter in. This is when you type something in the chat box, you call that tokens. So every word or every set of words, every set of characters counts as a token. Think about that as a coin. You put it in a box, you flip the switch, and you get a gumball out. Now, there's two separate pieces when you're building these AI models. There's the training portion of it, which is when we usually think about data centers and spending a lot of money and very large companies putting a lot of effort into this. That's in the training side of things. So training can take, months and years and huge amounts of data, huge amounts of energy, lots of data sets. And then there's the actual models, which the inference models, where you put the token in and it spits a set of values out. Now, how many times you do that depends on how costly it is. You might have something that takes 1 token, 10 tokens, 100 tokens. That's called the context window, the number of tokens you can put in that it can pay attention to between you asking it questions. Okay. So let's say that you and I are having a chat. I ask it a question, it gives a response. So I gave it a token, it gave me a set of tokens back, right? So then I ask the next question. It doesn't just take the next question. There's no intelligence there. What it does is it takes all 3 sets of tokens, the first tokens, the tokens it gave me back, and my new tokens. You pass it back in, and it gives me an even larger set of tokens back. So now as I'm building, I kind of build a stack of all the tokens that I've given it, and it gives me back, and I give it. And every time I go in for another question or another request, another set of coins in the gumball machine, I hand in this larger pile of money, and it gives me another response. And so as that large pile of tokens grows, that's your context window, the total context that an AI can keep track of. And at some point, you run out of tokens, which means if you've ever used an AI and you're talking to it, and it kind of loses context, it's like all of a sudden it doesn't remember something that you said a while ago. Mm-hmm. It's because you hit the maximum limit of your context window, and it doesn't have enough room to store the earlier items in that list. And it usually keeps it on the list, so it pops the top stuff off, so the stuff you asked it first disappears. Now, more advanced modern AI models are doing something called compaction. So they get to that limit, and instead of just throwing stuff away, they're like, how can I summarize this and hand it in as a smaller set? So AI is getting a little bit smarter, but that's just because as we build these AI systems, are getting more efficient at understanding how to use them so that it doesn't lose context and can stay a part of the conversation for longer.
You said something earlier that I thought was important. You said it's not intelligent. Mm-hmm. So what do you mean by that?
Yeah, so when you think about AI systems, so an AI system gives you give it a set of tokens. Let's say, what day of the week is it, right? And it doesn't necessarily know what day of the week it is. It has a huge set of data that gave it a bunch of answers, and based on those answers, it has a percentage chance of what a likely answer would be. And so the likely response to that on all the Reddit pages on the planet or all the text messages that you ever sent is, today is Wednesday. Now, it might have an API call in the back end to look up data. That's a whole different thing. But if it has that API calls, it's no longer the gumball machine. It's extra code that somebody wrote to understand the context and to go get extra pieces of information to hand the AI. And it might have a loop inside where it asks that gumball machine multiple times. So it might say, hey, this is a question. Does it need to call something else? It'll call something else, figure out what day it is, right? And then the combination of those will be passed back in, and it'll tell you the actual day of the week.
Question, teacher. What's API?
Oh, great. So application programming interface. Okay. So what that is when you type in a web address, like http://www.google.com/search, right? That search is actually what we call an application interface. And so it has a set of pieces of input and pieces of output, and you're just handing in a couple parameters of data, and it has an expected return format, which is usually what's called a JSON file. JSON is a text file that is think of it as a complicated text file with just data sorted in a way that you can parse through it and understand it, right? But it's literally just I pass this data in and I get a string of data back out. Now, a string is just text. So every time somebody says string, they're just referring to a string of text. But in computers, that string isn't just strings. It's ones and zeros on a piece of hardware, like a memory chip. And those ones and zeros in the memory chip, like if I have a letter and that letter is A, B, C, D, E, F, G, and then 1, 2, 3, 4, 5, 6, 7, and exclamation point, colon, parentheses, whatever, all those have a number. So let's say I have, 27 letters in the alphabet, and then I have, is it 27 letters?
26?
26 letters in the alphabet. I'm intelligent, I swear. So 26 letters in the alphabet, and then you have, 0 through 9 for numbers, and you have all the different types of extra characters. So if you go into your character files on Microsoft Word or some other application, you look at your characters, like there's this huge list. Every one of those is actually a number. So people like to hit the Alt button and go 0057, and you get a specific character popping up. So that's the number that is assigned to that letter or that symbol. And when it's stored in memory on a computer, it's literally just a number. So when I say hi or hello world, HELLO, each one of those is a very large number of the potential possible letters that could be at that specific, what we call an index, so that place in the sentence. So all a string is a list of numbers in a huge list, and then every single one of those numbers represents a sentence. So for an AI system, when I go back to it's not intelligent, the AI system gets 0011, 0011, 0101, 0011, and that might refer to 15, 25, 30, 10, 5, 72, like whatever those characters are. And then it has a mathematical principle of what types of characters are returned in what order. So it's kind of like you're looking at your iPhone and you ever have like those options of like the next word, the auto select.
So you're saying it's making an educated guess every time?
Every time you pass in a selection of tokens, there's an educated guess.
So it's a probability thing.
That's right.
And not a certainty.
100%. So it doesn't know the answer.
So is that why sometimes you can ask the same question and get different answers?
That's exactly right. So when you think about AI and you pass in a string of characters, at every number, when it's trying to decide what number to hand back, what set of characters, what word to hand back, there's a probability of the next word, right? Like, so if you say, hi there, like the there is a very high percentage chance of coming back next to hi, right? Let's just pretend. I don't know what the math actually looks like, but let's just say hi there is a common phrase. Or good, actually that's probably better. Good morning, right? Like good morning is probably very, very common. So good is followed by morning a very large percentage of the time, probably, equal good evening, good night, like whatever those percentages are. So you have the percentage chance of either. Now, in the reason LLMs, large language models, have hallucinations, or the reason you can ask the same question and get different responses every single time, is because at some point it's a 50-50 chance to get two different pathways. And that's on every word. So if I give let's say I gave the same sentence to a large language model 3 times in a row, every time there's a 50-50 chance that some part of that will come back differently. And so the large language model just makes a choice at that time, or what's called an RNG, random number generator, a random choice between the 50-50 split on what should come back. And so it's what we call non-deterministic, because there's too many 50% chance responses to things in the human language.
It sounds like 50-50 based on 50-50 based on 50-50 would almost ensure a lot of inaccuracy, right? A lot of potential for error. So what kind of guardrail is in place to...
Yeah, you're going to have to eat the mic a little bit more.
What kind? I'm still not used to this.
That's okay. That's okay.
What kind of guardrails are in place to prevent all of that potential error stacking?
Yeah, so a lot of the time, the primary control is in the data set that you train the model, right? So if the model has a whole bunch of garbage data in it, then it's going to give you garbage answers.
Is that why certain LLMs have a proclivity to give a certain type of answer relative to others?
That's right. So every language model is trained on different data. So it doesn't matter whether it's text or audio or video or pictures. all of that's just data, and all of that has, likelihoods of different types of responses. And so I think images kind of demonstrate the most accurate version of how LLMs work, is because I give it a description of what I want, and then I can ask it for the same thing 5 times in a row, and it's very different 5 times in a row. Like most frequently, we've gotten better at trying to get it to, like, we tweak the input in such a way that it gives us a much more similar output every single time. But yeah, there's always variance, and it'll never be perfect. It's like if you learn how to memorize a speech on a stage play, that's rote for rote. But, sometimes the light's different. You're feeling different that day. You miss a word. You drop a line. Like, the human brain is pretty accurately similar to an LLM, but we have a lot of different. We have the prefrontal cortex, and we have different pieces of the brain that is accessing memory. So we have many different mechanisms. Just the memory access of things and the probability of answers is the closest thing to a large language model, because it's, it's like neural nets, percentage chances of answering to questions and going to different nodes, i.e. different neurons in the brain, to find answers.
How are we doing on time, James?
Good question. Plenty of time.
Okay. So there seems to be a lot of conflicting information out there on AI. As you've just gone over, it's not a conscious thing. Not yet, right? It's not there's a term for that, right? Once we've reached that event horizon where computing is able to basically become self-aware, or it's so advanced that it effectively
so that
seems self-aware.
That's called AGI, which is artificial general intelligence.
Okay.
So the thing that differentiates most AIs from human AI, or humans' intelligence, is, and I hate the word artificial because it is intelligence. It's just digital intelligence. I think digital intelligence makes more sense than artificial. So it's digital intelligence versus biological intelligence. It's probably the easier way of thinking about those two. But AGI is a human is very good at general things, right? You can wash clothes, you can shoot a gun, you can drive a car, you can fly a plane, you can play a video game. Like, all these things are very complex tasks that require a combination of motor skills and, vision and sense of smell and balance and planning. Like, all these things, they're very, very complex. So we have a complex system in our brain that allows us to be very good at generalists. So you can do a lot of variety of things, where most AIs are very specific. I'll give you a good example. You think about a lot of these chess playing, like, IBM, I don't remember, was it like Big Blue or something? Like, they had this big AI that could play chess and beat a lot of the grandmasters. It's only good at chess. Like, it can't do anything else. Sure. Just chess. And so, you have a lot of these artificial intelligences that are really, really good at playing video games. They're really good at, racing cars. They're really good at driving a car, but they're just not really good at a lot of general things, like learning new talents and applying that to new things rapidly and very, very quickly. I can teach my son how to do something in like 5 or 10 minutes, and it would take an AI months and months and months of training to get it to have enough data to be able to process that new task. And so, it's not rapidly learning on us. And every time we want to learn, you're talking about months of learning. Now, we are shortening those learning cycles. We're, 100x, 1,000x more efficient at training these models than we were 5 or 6 years ago. So it is getting more efficient and faster, but we haven't reached, like you said, the threshold of artificial general intelligence, because you have to train a model for very specific things before it's good at it.
So, not to go too far down the rabbit hole of AGI, but so it's really AGI that people are afraid of.
Yeah, I think AGI means that the machine. I had someone describe it to me this way, right? Is the speed of silicon chips today is, in the gigahertz. So, if you had a artificial general intelligence that was as I want to say aware as you and I, and it could choose to do harm, it, inside of a computer, it's like a couple seconds to us, or let's say a day for us. It could be the equivalent of 1,000 years for a computer. So if it's the same, just as intelligent as the smartest human, and has 1,000 times more time to solve problems because time is irrelevant and it has enough CPUs and clock cycles and all these other
Memory.
things and memory to be able to manage these things. It could do a lot of dangerous things. I mean, Terminator is, the classic response.
Mm-hmm.
However, I don't think of AI that way. I think of AI as, just like I think about all technology. Technology evolves around the human use case, right? So we're building AI based on human intelligence. It's all of human writing. It's all of our literature. It's all of our ideologies. It's all of our, historical grievances. It's all of the things that we've learned. And it's amazing when you use something like ChatGPT or Claude, because you ask it a question and it's very good at nuance, actually. Like, it's better than humans are at nuance. You ask it a pointed question about something like, hey, is it black or white? Is it red or blue? And it's like, well, some people think the pros and cons are this, and some people think the pros and cons are that. So because we're training it to be the whole sum of all the human experience, the likelihood that it's going to go completely,
I guess that brings up a question. Is it better at nuance, or is it masking the fact that it's making a 50-50 calculation, right? And if it's making a 50-50 on top of a 50-50 on top of it, and so on and so forth down the line, doesn't that mean that at some point, if the sum of its information, the sum of its training is based on the human experience, well, we've got some painful things in our past, right? We've
Sure.
And present. There's a lot of violence in across humanity. There's a lot of victimization of someone other, right? Someone who's not in your group.
Tribalism in
Tribalism
human
and
cultures.
Even at an down to the individual level. So,
Sure.
Would it not be a concern that a system that doesn't have necessarily any moral guardrails, right? Because why would it? If it's only thinking practically, and I say thinking rather loosely, but if it's only taking in numbers, information, data sets, and it's coming up with 50-50 answers based on that, eventually wouldn't it fall on something negative?
Yeah, so this is where data scientists and people are trying to be very cognizant of what we're building. There's a lot of competition in the marketplace to have the best model, which means, if your model swings too far to one direction, you lose. People don't really think about it this way, but if I'm being very narrow in how I'm training something, like let's say a specific culture or specific beliefs, like let's say Judeo-Christian traditions, like highly focus on Judeo-Christian traditions instead of Muslim traditions, or instead of, Buddhist traditions, or all these other, there's Hindu traditions. There's a lot of different types. If I only focus on Judeo-Christian traditions, the problem is I literally cut myself off of 80% of the world of people that are going to want to use AI.
Sure.
And so because we live in a very highly competitive global market, we want to make sure the data is actually as broad as possible, and we avoid tribalism, because that means these models are not sellable to areas that aren't like them. And so when you look at the models that are coming out of China, they're pretty much trained on the same large internet-wide data sets that everybody is using, because they want to make sure that every company wants to use those models, because there is an AI race and everybody's trying to have the best models. So if you start trying to trim the data out and making it go in a very specific way, you're actually cutting off entire markets and entire dollar signs. And follow the money, people. Always follow the money. They don't want to cut themselves off from those revenue sources for building data centers and training new models and getting access to NVIDIA chips and all that stuff. So there is a lot of incentive, and I think incentives is probably the best way of thinking about it, to not have bad data. And then on the cybersecurity side, on the responsible AI side, there's a lot of thought into what we call guardrails, to making sure that certain inputs to certain models aren't allowed, that we, if it does give bad data, we have multiple checks on the data that's coming out of it, that before we give that answer, we check it to make sure it's okay. So a lot of the times, you got the gumball machine. The gumball machine goes in and goes out, but then it goes into a set of other gumball machines that are specifically there to check the safety of the returned results. And if the returned results are bad results, it might actually rerun it for you. You might see a slower lag in the fact that the gumball machine is taking longer to get back to you, but that's because the back end system detected unsafe material to give back to you. Like, I don't know if you remember, there was a while there was like, I cannot answer this question. I cannot answer this question. And now the responses are a lot more natural and humanistic because they put a lot of time into building out those guardrails. So, and just remember, this isn't the AI. This is extra code that sits on top of the AI that acts as guardrails for both data that you're passing in and data that you're handing back.
But guardrails can still be subjective, right?
Of course it can.
I seem to remember, I'm not going to name them, certain large language models that for a while were returning some pretty interesting search results.
Mm-hmm.
Like making the founding fathers into women and people of color repeatedly over and over, and just would not, it seemed like they refused to or were not capable of returning a response that was actually historically accurate.
Yeah, I think
so. What is, and not all of these LLMs were doing this. It was certain specific ones. What is, what kind of guardrails would have or should have been in place to prevent something like that?
So I don't think you're going to prevent that kind of stuff, and I think that stuff is okay in iteration. They were trying to tweak the data sets in a way that they thought were more equitable, and equity matters. There's a lot of data sets that we don't want to include people's birthdays, or we don't want to include people's genders, because AIs make bad decisions based on bad data. So I'll give you a good example of this, okay? So a woman who had a very large financial bank accounts, like a lot of money, she was very wealthy, she applied to a loan. And the loan, the information for her credit score and her credit card usage all went into an AI system. Now, because her husband was working most of the time, she was the one on her credit card that was doing most of the spending for the entire household.
Okay.
She was going shopping. Her husband and her would talk about vacation, so she'd plan the vacation. Like, she was at home. She had more time. She just was doing that. But her husband then applied for the same loan with the same financial statements, the same account balances, the same assets in their portfolio. She was rejected for the loan because of the fact that she was a woman and the fact that she made most of these transactions. So the combination of these two data sets, the AI is like, this person can't get this loan. But the male of the household with the exact same documentation came back positive. Why? Because the AI was biased. It made a decision based on pre-fit data sets. And so a lot of the time when we're trying to build smart data sets, we think we're being equitable by including certain things, and then we include those things. So you think about the founding fathers coming back as something else than what they are. Like, Thomas Jefferson doesn't look like Thomas Jefferson for whatever reason, right? We were trying to play with the data to see if we could be more equitable. And what we got as a result was something that failed miserably.
Bad data.
That's right. So we're learning over time. Those models no longer make those problems because they tried them. They tried those things. They failed.
Got backlash.
They got backlash. All backlash is feedback from your customer base to tell you that something isn't working the way you want it to. And that happens in every product. The thing about AI is it's data. And when you start tweaking with data, a lot of the people that are leading the AI race think that honesty in the models is the best thing that you can possibly do, because honesty actually gives you the most accurate answers. And so some companies do that, but then now you're having a very, there's some very crude models out there that people are like, oh, it allows you to strip clothes off of people. Yeah, now you're fighting the other boundary where it's
looking at you, Elon.
but now it's becoming too free, right? So it's like some guardrails are good, some guardrails aren't. Some tweaks of data are good, some data aren't, and this is just a constant learning process.
So that brings us to the question: who is getting to decide what the guardrails are? And just because there are guardrails in place, is that enough to ensure that Terminator kind of possibility never comes around?
Yeah. So again, AI is not intelligent, and it only has access to systems that we give it access to. So when you think about how AI works, again, it's a gumball machine. I put a token in, I get a token out. It's just a string. Mm-hmm. It doesn't give you access to anything. So there's another set of technologies. We call this agentic AI, and you probably have heard of MCPs. So, MCPs are what's called model context protocol. So essentially that's a language that we describe that API, that application protocol interface, so that an AI says, "Oh, I need to get more data," right? So when you say something to an AI, that actually doesn't go into the LLM. So you get essentially put into a next what's called prompt engineering. So we take your question and we put it in a little additional prompt, and we ask the LLM, "Hey, do you need more data for this? Here's the question. Here's the extra data. What do you need?" And the AI will just give out a string, and the string that comes back will say, "I need extra data for this, 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 and this." And that will come with data sources, and it will go to an MCP server, and the MCP server says, "Do I have these data sources? Let me go look." It'll have another LLM that'll inquire the MCPs for all the available data sources. So now it gets a list of what it has access to. That gets handed back in terms of the LLM, like, "Well, what do you need? Here's the data sources that are available." The LLM reviews that context and is like, "Okay, so based on this question, based on what I need, this API is the data that I need." That'll go back to the MCP server. It'll go pull the data that it wants. So now you have the actual data, right? And then it'll, or command, go do something, go turn on my lights, go do whatever. Like this question is, the user told me to go turn on my lights. I need access to something that turn on lights. MCP server, do I have something that turns on lights? Here's a list of APIs. Oh, this over here allows me to turn on lights. Great. I want to go turn on lights. The MCP server says, "Hey, go turn on the lights." Did the lights turn on and off? Yes, it turned on. Hey, MCP, or hey, LLM, I turned on the lights. Here's what happened. And then you get your response. So all that happened in the background.
So that sounds very energy intensive. It sounds like there's a lot going on, a lot of queries.
It can be. It depends on the types of actions it's trying to take and how like every time you open an application on your phone, there's, hundreds, if not thousands of APIs, and it might happen in a split second. Like a computer is very, very, very fast. I can have 1 million operations in the blink of an eye, and you don't even realize. And remember, a gigahertz, right? Every hertz is essential. Easiest way to think about it is, that's you have every hertz is thousands of operations for a CPU to go handle. So every time you're like, "Oh, there's that sounds like a lot." 1 million operations isn't a lot. When you get to hundreds of millions and billions and trillions of operations, yeah. But it also depends on those data sources, those APIs that the MCP servers are calling. Are they giving you data? Now, data is slow to transmit. So if I'm asking for a very small amount of data, it might be really, really fast to call that many times. If I'm asking for a lot of data back, like think about a web search. So if you ask an LLM to go look up something on the web, do deep research, right? It's slow. Like it literally takes the LLM 10 minutes to go do this sometimes. Well, what is it doing? It's calling a web API. It's pulling down your web page. If you don't know, your web page is just text with a bunch, like you can go look at the hypertext markup language, HTML, underneath all the tags and stuff. You can go to your web browser and say, "Look at the source code." It'll give you all the source code. So your web browser takes the source code and makes it look like a pretty picture, pretty website, right? LLMs don't look at it that way. LLMs are like, "Hey, call these websites, give me a ton of text. That's all my tokens. Is that text available to have the data that I want?" And then it's doing a whole bunch of actions to parse through that data to find the data that you asked it to go find, right? And then once it finds the data that it wants, it gives you the response. That deep research might have, 1,000 web searches, and it's reading 1,000 web pages. Those are going to take time because every web page has pictures. Every web page has a lot of text. Every web page has its own server. That server might be geolocated all around the planet. So there are some things that are very slow, and there's some things that are very fast. It depends on what you're asking it to do and what it has access to do.
And the guardrails that you mentioned earlier, those are what confine what it can look at?
Yeah, so in cybersecurity, we typically think of two things. What do you, as a user, have access to go do? And what we want to do is we don't want an AI system that can go do everything, right? Because an AI system that can go do everything is very dangerous, right? But if I give an AI access to do certain things based on what you have access to do, and you're allowed to go do these things, you can pass your permissions to the AI, and the AI can only do what you can do. So if two different people ask the AI to do different things, the AI might be able to do it in one case and might not be able to do it in another case. So we're building these intelligent systems in where AIs have limited access to certain APIs, and then based on who accesses or asks the AI to do something, it might also be limited based on who's
So
asking.
it's not
you to
the
do it.
AI deciding who has the credential. It's only referring to a list of people who have the credential. So it's still people deciding.
Yeah, yeah.
ultimately.
So if I log into a system and I ask an AI to go do something, it has my access, right? Because I gave it. Now, you don't have to build an AI that way. Remember, an AI, an LLM is only a gumball machine. It's all the other code in the system that some developer had to write to give that AI access to other things.
Which brings us back to the can we trust it question, right? And how safe or dangerous is it? If somebody can decide, let's say you have very noble intentions, and I have very ignoble intentions, right? Malicious intent. And I want to, let's say we're coders of equivalent skill and experience, and we have the ability to do this, because I do not. But in this metaphor, let's say we both have this capacity. We both have the time, we have the funding, the equipment, whatever software is necessary for this to begin with, and we both write a model. What's to stop me from passing on my malicious intent, my malintent, my lack of morals, whatever you want to call it, into that set of APIs or that large language model versus yours? And what's to stop mine from somehow harming people?
So you make a very good point. So you're somebody that we would call in the industry a threat actor or a black hat.
A bad actor.
Yeah, bad actor. Yeah. And so bad actors exist. I mean, we have malware, we have ransomware, we have, people that are, we have very large threat surfaces. You have, DDoS attacks.
What is a threat surface?
You're asking all these questions. I can answer them, I swear. So a threat surface is, if you think about all the ways that a threat actor, a person could attack you, every single one of those things is your total attack surface.
Angles of approach.
That's right. So how would you do it? So if I'm talking about a building, well, they can go in the front door, they can go in the back door, they can go in the windows, they can come in the roof, they can go through the basement. Like, what are all the different ways that they can attack you? And that full list is your threat surface of the possible mechanisms that they can use to attack you. So absolutely, there's threat actors. Good guys are using AI, bad guys are using AI. I think the difference is the number of people that are trying to do good things far outweigh the number of people that are trying to do bad things. So if you look at the weighted distribution of good people versus bad people, the mass majority of the society, people, we've done tons of research on all of this. The mass majority of people want to do the right things for the right reasons. They always have good intentions. They may be lacking knowledge. They may be lacking resources, but in general, people try to do good things, right? Based on what they've been taught. So if somebody's been taught wrong, they might make a bad decision. But if
They might be ignorant.
that's right. That's not them trying to be bad.
Good in here.
They're trying to do the right thing, right? But there is a certain portion of the population that absolutely are just trying to be, for whatever reason, they're bored, or there's a lot of these hacktivist people that want to make a point by, bring down the man and bring down the monetary systems or whatever. So there are threat actors, and they have a variety of different reasons. However, when you think about the number of companies that are out there that are building counter intelligence and counter AIs to fix these things, when we see an increase in attacks of a certain type, and AI is definitely becoming a certain type, people find countermeasures in the industry, and then we start rapidly deploying those countermeasures to everybody. So, I work for a large cloud organization. So when we identify a specific threat vector, we implement it and we roll it out to everybody. We use a lot of the basic capabilities.
Everybody, you mean everybody within your organization, or everybody globally?
Everybody that's using the software that we manage. So if you have a company that's an antivirus company, just a random antivirus company, and they detect a certain type of virus, they create a patch, and everybody that has their antivirus gets that patch. So that could be 10 people, that could be 100 million people, or it could be 1 billion people. There's depends on your system, depends on the software.
It sucks for everybody else who doesn't have whatever.
The other thing that's really nice about the cybersecurity industry is that we're very open books to everybody else about known threats in the industry, because we don't want, if your compromised, it makes everybody else less safe. It's kind of like herd immunity, right? Is if everybody's immune to it, then there's less potential for cross-contamination and cross problems. So if your systems are down and my systems rely on your systems and I'm safe and you're not, then all of my systems are impacted.
What if our systems have no relevancy to each other? Then we're not connected in any way, shape, or form.
Sure. I mean, that happens, but in general, the community, there's a lot of service providers that are globally used, that are the biggest service providers on the planet, and everybody wants to be safe together.
From a layman's perspective, it sounds like we're relying on a bunch of goodwill.
Sure. But we're not. We're relying on money. Back to the incentives conversation, is if you take down my business and that business costs me hundreds of millions of dollars for every hour that I'm not making money, it is in my best interest to make sure that my internet and my systems are safe. And if you, for whatever reason, can cause any impact at all to me, I want to make sure you're safe too. And because even if it doesn't directly impact me, it might indirectly impact me, because what if all of my customers use you and all of my customers are not using my stuff because you're impacted? So, you ever hear like the Kevin Bacon thing, like everybody's tied to each other by 3 or 4 steps? The same thing can be said in technology. Everybody had that AI diagram for money going around. Believe it or not, you can literally relate everybody to everybody within like 3 to 5 steps very, very easily. There's a lot more interconnection to the world than you think. It's not just goodwill. It is huge amounts of money. And when you're talking about a $100 trillion economy globally, people want to protect their businesses. It's not just about goodwill. It's about all these businesses want to keep making money. So yeah, they want their jobs. They want their houses. They want their kids to have food and their, heating and
their
cooling.
Power grid to work.
Everything. So, people often forget that, there is the altruistic point of the incentive, but fundamentally, these are large corporations and they make a ton of money, and that money is a driving factor, and they do not want to be impacted. And when you see bad actors, you're impacting my money.
They don't want their customers being impacted.
Customers are money.
Which means you.
Customers are money.
Yeah.
Business.
So
I think somebody once said, everybody is a servant. It doesn't matter what job you have. It doesn't matter what business you're in. Everybody is a servant. Yeah. So if you're a CEO of a multi-billion-dollar company, you're a servant to everybody in your company.
Yeah.
And to your customers.
Board.
And the board of directors. It doesn't matter whether you're an auto mechanic. It doesn't matter whether you're somebody at a grocery. We all serve somebody. And if those people that we're serving aren't being successful, then we're not successful.
So coming from a military and, intel background, the good guys have to be right every time. Right? The bad guys just have to get lucky once. Sure. Is it the same way in AI and in this black hatting that you mentioned?
Maybe. I don't know. I think that there's a concept in cybersecurity called defense in breadth and defense in depth, right? And the concept is don't just have one way of protecting yourself, and have multiple layers of defense. So at every layer, whether that's your API, so your website, or so when you go to a website and you're typing in your password, right? It's not just a password. You get a text message on your phone, which is called multi-factor authentication. So you have to verify that yourself. And then you go to another page and it's like, click this button. It's called a CAPTCHA, like to verify that you're a human trying to click this. So you get like 1, 2, 3, 4, 5, 6, 7. Like, you'd be surprised how many layers of defense there are in a lot of these systems. So, if the way most of us think in computer science, cybersecurity, is the hacker might get lucky and get through 1 line of defense,
okay,
or 2 lines of defense, but I have 7, and if I have the right 7, they can get a certain way in, and then more interestingly, I can then use that data, because I can detect that they're breaking through certain layers of my defense, to understand how they're attacking us, so that I can change our patterns of protection to better thwart them. So next time they don't get through 3, next time they only get through 1.
So what's to stop somebody with that kind of familiarity, that kind of background and experience, somebody who's worked on the good guy side, for example, or for instance, what's to stop someone like that from having a really bad day at the office, a really bad month, a really bad year, came home and his wife was cheating on him, whatever. What's to stop that guy from creating a model that intentionally gets around those defenses?
Let's be careful when we talk about models back with AIs, right? Is creating a model is, hundreds of millions, if not billions of dollars. It's a lot of effort, a lot of data centers, a lot of cost. If you have a bad actor, most of the time bad actors don't have
that kind of funding.
Do not have that kind of resources. So they might use an existing model and write code on top of it. So a good example is that there's if you don't know, there's a lot of bots that are out there that are attacking things more regularly because I can use this agentic workflow to say, hey, I'm going to create these different, I as a bad actor, I'm going to create these MCP servers, these APIs to go do all this bunch of bad stuff. And then I'm going to go build a script. And then I'm going to build a script and that calls an LLM. So it's able to do something. Now, historically, these threats are code that are very repeatable, right? So it used to be where I have a virus, it has a signature, I can detect that virus on every single computer that it's touched. I know it's the same virus. With AI, the AI writes a different virus, a slightly different threat vector every single time, and it's no longer just one attack. It's I have a mutating virus or a mutating attack vector that is changing every single time, and I have to be able to be more creative in solving it. So the answer to that is we have AI that can detect these multiple different types of attack patterns now, and it starts seeing similarities or starts seeing, these large amounts of data sets because it can view more data than a single human can at a single time, and it starts stitching together the fact that somebody's misbehaving and they flag it. Now, that doesn't mean that we have an answer to that bad actor. It means that we've identified that type of a problem, and now we can start building remediations and answers that can come in and try to prevent it and limit it and control it and stop it from doing that bad damage.
And I'm assuming that applies even if that said bad actor was like a nation state, because some guy out there is going to go, but China, right? Or but Russia, but Korea.
So let's talk about nation state level threat actors, because I think it's important. So I worked in industrial IoT, Internet of Things. So I work with
verbally slap you.
I use way too many acronyms. So you have, for example, you have gas turbines, nuclear reactors, you have oil and gas pumps, you have large refineries, like all these things are what we call critical infrastructure, right? So in these critical infrastructure places, you have hardware that has sensors that is taking data in and then evaluating that data and then trying to decide whether or not the machine is running safely. And if the machine is not running safely, we turn it off.
Okay.
So those are industrial safety systems. I worked on those for like 20 years. Okay. You have to realize that a power station, whether that's nuclear, solar, wind, oil, gas, coal, whatever, is a prime target for nation state level actors.
Yeah,
right.
Absolutely.
If I can disrupt your power grids, I can control your country and dictate where you have defenses and where you don't have defenses. Mm-hmm. So we had to build our software all the time and our hardware to live in nation state level threat actors. Okay. So what this means typically is you have a isolated network that's not connected to the internet. You have an armed guard. You have a fence around the perimeter. You have machines that are unplugged from every network possible. And then you build in many, many layers of protection to make sure that a nation state level actor can't do it. Now, let's go look at Stuxnet. Stuxnet is a very common threat actor or cybersecurity well-known
attack vector.
Attack event. Let's just say attack event. And a nation state, who shall be unnamed, spent enough resources to change the code on a chip that was triggered based on a certain set of use cases, and then that chip was mass produced and sent to every place on the planet, but it only affected centrifuges in the Middle East.
Yikes.
So look, nation state level actors, look, I have a whole team of very, very smart engineers, right? if I have millions of dollars and hundreds of engineers that are as smart as me, they will find a way of hitting their target, guaranteed. I've learned one thing in cybersecurity: nothing is safe. And if I can't do it digitally, you'd be surprised how many times just there's something called spear phishing attacks. Like, I can get your credentials. I can be like, "Hi, this is IT, and your refrigerator's running, and I need your password to help you reset it." Whatever your excuse is. More times than not, people are actually weaker links than all of our cyber systems, and people get credentials. People pick up USB sticks in the parking lot, or at least they used to. They plug them into their machine, and then all of a sudden hackers have direct access. So there's always been threat actors, and social engineering is easier to break than digital engineering. And so, yeah, there will always be threat actors. We can't get rid of them. There will always be attack vectors. If a nation state is after you, they will guarantee that they get you. And most of the time when we do all these due diligence, it's, we're trying to check all the check boxes to say we did the best that we possibly could to make sure that they didn't do anything. So that if we get to a court of law and we have to prove that we did the best that we could before a nation state level actor stopped us, we are able to prove it.
I'm not sure you're making the average English speaker feel very comfortable right now. That's not the direction I thought you were going to go with that. That was kind of my assumption when I asked the question. It was kind of a leading question, but I didn't actually expect that answer. So then the obvious retort would be, well, then what can we do?
The best that we can do, and constantly make progress in a good direction.
Okay.
And there are more people in the good tide towards good results and good outcomes than there are people trying to do bad outcomes, because most of us realize that we want human society to be successful, and we want people to live long and happy lives, and we care about the planet, and people care about, again, back to that thing, the mass majority of people want to do the right thing for the right reasons.
So assuming that's correct, and I'm not going to get into the implications there ethically or morally or even sociologically, we can all agree that AI is a pretty powerful kind of a force multiplier, right?
Absolutely, yeah. I
think most people alive today are starting to see that and believe that. So the threat of force being applied to us aside, the other side of the coin is, well, what can we do with AI? And the other concern with kind of attached to what can we do with it is who's going to be affected, right? There are people who are worried about the Terminator effect, and then there are people who are just worried about losing their job.
Sure.
So what kind of people need to be worried about that, and what kinds of people don't?
Yeah, I think we'll get to the second question on jobs, because I think that's an important topic, and we got some time, so we can kind of cover that. I think from the perspective of Terminator, I think the possibility always exists. I think that possibility is so low because of the direction that we're going that it is almost, the likelihood is zero. So there's a difference between likelihood and probability. So probable, yes. Likely, no. And anybody that's a doom and gloomer, look, I like to believe that past performance dictates future behavior. And when you look at everything in human society over the last 7,000 years, people like to have progressophobia, but everything has gotten better, right? Every person today lives like kings compared to people 100 years ago. 100 years ago, 95% of the population was in abject poverty, and today it's less than 10% in almost all of the developed world. So when you look at the fact that things constantly get better, it is much more likely that we have good positive outcomes from AI than negative outcomes. And even though there's negative threat or negative bad actors out there, the likelihood that they will win because of the mass majority of people that are trying to do good is very unlikely, which means that, if an AI system does become a problem, I think people will want to do the right thing quick enough before it gets out of control.
I view that in the same light as like nuclear weaponry. Right?
Sure.
The probability that something really bad with nuclear weapons happening in the future exists. The likelihood, because we all have a vested interest in not nuking ourselves, right? It's
very low.
Effectively zero, right?
I don't know if it's zero.
very
very
close
to zero.
Very
yeah.
close.
Yeah, yeah.
Maybe zero is probably wishful thinking, but it's the same thing with AI causing some catastrophe. Right?
There is definitely a
Effectively-
possibility.
Yeah.
That is a probability. It is not a likable or a likelyable outcome. I don't know if that's the right word.
No, it's not.
It's probable but not likely.
I believe the word you were looking for was likelihood.
There you go. That's good.
So again, assuming there's no Terminator risk, we then flip the coin around to the more likely, and that's jobs being affected. Right?
Yes, absolutely. Every job will be affected.
AI is definitely going to enhance certain people's jobs.
Yep.
It's going to make them more effective. It's going to make them more efficient. Probably going to help them be more strategic and tactical in how they approach whatever their work problems are. But then there are going to be some who are affected. So what are the types of people that you think are most likely to be affected in a negative sense?
Yeah, look, AI is not going to take people's jobs.
And he's not a fortune teller, but I'm just putting him on the spot.
Yeah. AI itself is not going to take people's jobs. I think that somebody that can use AI better than you
Sure.
is going to take your job.
Yeah.
And I think that certain jobs are going to change significantly over the next decade or two. Probably even faster than that. Probably the next year, 2 years, 5 years. We're actually seeing rapid transformation in the marketplace. But let me kind of put it in perspective. So if you go back to 1990, 99% of the tech jobs today did not exist in 1990. Okay? It's something close to 90% of the jobs didn't exist in 2000 that exist today. So technology like the internet radically transforms things. The world has changed radically since the time of the internet's invention, and every major transformation changes. So let's go back to, just as an example, the automated teller machine. So when we created an automatic teller machine, automatic teller machine, everybody thought that all the bank tellers would be out of their professions. Turns out that no, people like to talk to people, and we actually have more tellers and more banks than ever before because we built more of them and people had more access to money. Now we are seeing a decline as cell phones get new able to get your credit card and everything on a cell phone. That's a different technology transformation that's kind of addressed that. But now let's look at another one. Let's look at the loom. So when people created the loom, they thought that all the knitters and all the stitchers and all the people that fabricated clothes were all going to go out of a job, and they did. To be replaced by people that work with looms. And now we have more clothes at this point in human history than at any other point in human history. We have massive amounts of clothes every single day. So these transform it. The same with the internet. It's like all these jobs are going to be lost now that we have the internet. All the storefronts are going to be closed now that we have the internet. Turns out, no, now there's a price point where something in a store versus something online makes sense, where you ship it to somebody versus you don't ship it to somebody. Like there's a lot of different variables, but we've actually have more consumerism than we've ever had and more people working in warehouses than ever before. Now there might be subtle shifts with AI on that. So look, all these technologies do one thing, which is they take the stuff that you don't like to do and they automate it away, right? So you going to a bank to get access to your money so you can put money in your wallet so that you can have coins and cents and quarters and pennies, although we just stopped printing pennies, pennies and quarters and nickels and dimes and dollars and bills. Now I have a credit card, and then my credit cards all go away. I don't have to carry 10 credit cards. Instead, I just get a cell phone or an Apple Watch, and now I have access to my money everywhere. So every single thing that we invent and we do as humans just makes our lives better because we're getting rid of the nuance. So let me give you an example of AI. So there's a bunch of things. I think it was called Clawbot. I forget what the new name of it is, but there's this new agent that's out. It's an open source software, and you can connect it, which I do not recommend doing it because very large cybersecurity concerns that have not been solved yet. So please don't just connect it to a bunch of your systems, but you can connect it to your Slack channels. Slack is a chat communication that a lot of businesses use. You can connect it to Outlook for your email services. You can connect it to a bunch of your internal HR systems. And then all of a sudden I can say, you talk about if you're an executive assistant, your job is to work with the executive to schedule meetings and find time slots on their calendar. Dude, this bot does all of it. I just say, hey, bot, I'm thinking about meeting with these 3 executives next week, and I need a meeting. Can you please schedule the meeting? The bot will then email those participants. It'll wait for them to respond to you. It'll pull their Outlook calendars. It'll figure out what available meetings. It'll send them out a meeting request. They'll all accept it, and then it'll tell you, hey, I scheduled this meeting for next Wednesday, 2 p.m. was the best work for everybody. But it personally emailed and talked to each person, and the emails are nice. It's like, hey, John, this is James. I'd love to have a conversation with you on such and such topic that I know that you did a webinar on that last week. I'd love for you to do this other topic next month. Are you available to maybe talk briefly next week? And, we can talk about you coming on my podcast. I don't know, whatever, or coming to my
If you're an
meeting.
executive assistant, I apologize if your boss sees this.
No, I mean, dude, these are like, people are rapidly talking about these types of tools, right? It's not just executive assistants. But then I think about my job. I schedule a lot of meetings. I don't make enough. I'm not high enough in the hierarchy to have my own executive assistant. So I do all of that work today.
Yeah.
So if I don't have somebody doing all that work for me, and I can just have a chat bot where I open up my Slack channel and I go to my executive assistant that's a chat bot and I say, hey, chat bot, please go do X, Y, and Z and schedule this meeting. It does all that work for me. I just saved 2 hours out of my week for all the meetings that I was trying to schedule.
So what you're saying is this is a very sharp tool, and those who do their due diligence and figure out how to use it and apply it in their workspace are going to get ahead faster.
Yes.
And those who don't are going to fall behind.
Look,
In short,
I was watching a podcast, where they were talking about who is that company? It's one of those companies that do all the reports for everybody else to tell them how their consumer reports need to go, and they do all the. I don't remember what the name of that company is off the top of my head, but the main thing he was talking about is that they've literally gotten rid of half of their workforce in the last year and a half. Dude, that's massive. And that's because most of what their people did was correlate reports and generate other reports. So they correlated a bunch of data and they generated reports. Well, now they have a whole new crew of people that they've hired that understand how to use AIs, and they use the AI to correlate the reports and have the AI generate it. So the AI does all the work, but the person can do it. And now you have one person that can do 10 reports at once rather than one person that can do one. So I can do 10 reports in a day instead of one report every month.
So it sounds good for people who are high productivity people. That could sound pretty scary for those of us who are not.
Yeah, but the point is once you learn how to use these tools, you become a high productivity individual. So that company, that CEO was talking about how their head count for their company, which is a very large company, has remained flat, where half the people lost their jobs because they no longer needed those jobs because of AI, but they've rehired the same number of people to do more work, more meaningful work, better work with far less churn. So now their entire organization has become 10x more efficient.
Okay.
But they had to hire the right people that understood those skills. So it has the same number of population, and people aren't trying to get rid of. Look, I look at it this way. I have never worked for an engineering firm that didn't have so much to do that we had a massive backlog of stuff that we wanted to add that we would never get to, right? Like literally features that 5 years later, the team has still not gotten to because it's sitting on a backlog and we don't have the bandwidth to do that versus priority stuff. But if I can have an AI that says I can do more, look, when I was back in the 1980s, back in the 2000s, early 2000s, we would do something. It would take an engineering team 6 months to go do.
Big difference between the 80s and 2000s. Which one are we talking
Sure.
about?
Let's say 2000s.
Okay.
So 2000s, I'd have a full engineering team, let's say a pizza box sized team of 8. And those 8 engineers do a certain set of features for, let's say a 6 months release. So after those 6 months, they get X amount of work done. Today, they do the same amount of work, or it looks like the same amount of work. They added a button. Let's say that team added a button and a grid and a couple charts to a web application.
To the UI.
To the UI. There you go. Yeah. That took them 6 months to go do, right? So today I had a conversation, well, not today, but a couple years ago, I had a conversation with an executive on LinkedIn, And he was talking about how come it takes my engineering team the same 6 months to deliver the same set of features on a new piece of software that it used to. Well, that old piece of software used to, have a file on the local computer that would have that button, have that graph, have that chart. The new piece of software, it doesn't have it on that computer. It stores it on that computer. It shares it with 1 million people on the planet. It makes it available in databases in multiple geolocations. So that is now available in the US. It's now available in the UK. It's now available in South America. It's now available in South, Asia Pacific. It's available in all these different regions, all simultaneously, scaled at appropriate. And it's not one person that's using that software at a time on a single piece of hardware. That's now scaled to 100 million users. So it feels the same, but the actual scope of a lot of these capabilities are astronomically larger. And we've been able to do that through building, infrastructure and building widgets that can do these really large scale type of jobs and reusing them at scale. It feels like the same amount of work because at the end of the day, the person just got a picture on your phone that you click a button and you see a graph. Mm-hmm. But behind the scenes, it's so much more work. So the thing that I'm saying when it comes to AI is the ability for you to do all those big dreams that you had in your software are no longer going to be in the backlog. They're going to be expected that engineering teams in the same 6 months deliver the world compared to what they could have delivered 10 years ago or 20 years ago.
1,500 items versus one.
That's right. Or the scale of what we're doing. Like I really look at it in terms of like universal scale. Like originally we were solving problems for you on your computer in your office in Sunnyvale. Mm-hmm. And then I was solving stuff in every single city in the United States. And then I was solving stuff on every single computer on the planet. And now we're sending stuff into space. And now that's going to solve a problem between here and Mars. And then that's going to solve a problem for the entire solar system. And then multi-solar systems. And then who knows, maybe even the entire galaxy. So the problems that we want to solve are larger and larger and larger and larger. And if we do not develop the tools for optimization, those problems become unsolvable.
Sure.
And so as we advance these technologies, will jobs change? Absolutely. But we will always be ambitious enough to solve the next bigger set of problems that we could never solve before.
So going back to the original question, what kinds of jobs are going to be impacted?
Every job.
Okay.
And that is an honest answer, is every job will be impacted by AI. I think we have another episode to talk about robotics, so I don't really want to cover that here.
Sure.
But, I personally think that every blue collar or white collar worker is going to be impacted by this. And this is going to impact the grease monkey at a garage, the landscaper or the builder at a construction site. It's just as much as it's going to affect the people that work at a warehouse or a supermarket. The same way it's going to impact people that work at, large companies that, Microsoft, Amazon, Google, you name it, every single big company, every tech job, everything, all executive jobs. Now, are those roles going to go away? No, you're still going to need an executive. Are your engineering teams going to go away? No, you're still going to need your engineering teams. No, are you going to have different mechanisms? I mean, the other thing to think about is when we used to have, before we had a lot of the current planes that transport goods all across the planet, mm-hmm. everything was shipped over ocean liners. Yep. The ocean liner technology has radically changed over the last several hundred years. You used to have just boats. Those boats turned into large ships. Those large ships turned into massive carriers. And the planes went from little tiny dinghies to these massive, 747s and bigger, mm-hmm. that can carry massively more amounts of stuff than we could ever carry before.
So effectively what you're saying is we're not looking at a mass replacement so much as a mass evolution of
exactly
jobs.
And that's the way I would think about it, is a not replacement, but an evolution, and it will impact every person on the planet. Like it is that foundational at its core. And we're just starting to scratch the surface. This is an exponential technology, and it's very hard for the human brain to think about an exponential curve, but we're still at the very beginning of this. And if I can tell you anything, if we're at the very beginning of this and we're 5 years in. Like if you talked to me about this 5 years ago, I'd be like, AI, it's interesting. Who cares? If you talk to me 3 years about it, I'd be like, huh, that's kind of cool. Like this is going to be really interesting technology. A year ago, I was like, wow, this is going to be crazy.
So it
And
really
this
is.
year it's
It
insane.
really is as big a deal as all of Wall Street is talking about it being.
I think there's different ways of thinking about it. I think if you think about it from the perspective that people are trying to sell models, I don't think models are the future of the AI business. However, at the same time, I think that AI will impact everything at some point in the future, and then it'll radically transform everything. So there's two separate things. Is AI models the biggest game changer? No, but it is the impact of how you can apply AI. It is the companies that are figuring out how to apply AI that are going to be the biggest winners, not just the people that create the AI.
Big and small.
Yeah.
Okay. Well, I think I think we should probably end on a high note.
Okay.
And the high note seems to be that, yes, AI is going to change the landscape of employment across the West and across the rest of the developed world, and eventually even to what we consider now the developing world. I don't think third world is politically correct anymore. But as much as it's going to impact that landscape, it would still behoove people in whatever industry they're in to get on board in some way.
Yeah, I would look at AI as a great enabler rather than a great conflict. People who historically have resisted against change are the people that have been impacted the worst.
Get left behind.
That's right. So my recommendation to everybody is recognize that this is the future. Start playing with these tools. I mean, a lot of people are already. Like I think Google's biggest boon was, they were far behind in the AI race, and then all of a sudden they just replaced the Google.com with a bot, and now you can actually just use it for free.
Yeah.
Right. I mean, obviously, if you want more than some basic searching, then you got to go pay for it. But it's figuring out new ways of doing it, so you have free access to it on a lot of the open platforms. Start playing around with it. Figure out how to make it work. I don't think the agentic stuff is going to be super consumable probably for another year or two. A lot of companies are still trying to figure out how to use the agentic stuff, but in the next couple of years, a bunch of these AI companies already have coworkers, and so a lot of companies are starting to deploy these coworkers. So you'll end up working with bots. Don't push against it. Just accept it and figure out how to, just like anything, improve your value. So let me give you an example, and then we'll kind of end it here. Right? Yeah, the pilot who flies the plane might go away at some point because we have robots that are flying the plane. But when somebody's walking through the cabin and giving me drinks and giving me a smile and helping me into my seat, I actually want a stewardess that's walking me through and helping that. Like there's the very personable jobs that are absolutely always going to be there. But I think that just as an example for self-driving cars, all the insurance companies just recently announced that anybody that had self-driving Teslas could get a 50% discount on all of their insurance costs because they're literally that much safer. So would you rather get into a car where you're tired, or you have a drunk on the road, or there's the potential of a new driver making a mistake, or a grandma making a mistake, or grandpa or whatever making a mistake? Like all those are potentials. Like people die every day in car crashes, and if I can reduce that number by over 50% just by having AI do it for me, the insurance companies are recognizing it. And so I think we're going to have a safer world. I think we're going to have a more productive world. I think that this technology is going to make everybody's lives better significantly over time. And I really think that we're looking forward to a world of greater and greater abundance. And if we fight against it, then we're not going to see all those benefits. But if we accept it and we work for it, then you'll get all those benefits from all the new technologies that are being invented.
That is mighty optimistic of you. I really appreciate that. Have you ever considered a career in politics?
No, not at all. That's a different conversation. And with that, we're going to end it for today. Thank you, everybody, and join us next time. This is
BC
and James for Perspectives. Have a great one, everyone.
You sure? No politics? What about when you retire from what you're doing now? I'd vote for you.
Nope.
No? I'd vote for you twice. See you guys. That really is a catchy tune.
I love this music, dude. I could literally just sit here and listen to this.
This would be a good canyon carving song on your motorcycle.
Oh, yeah, dude. Hell yeah.